this is the second method we try to solve this problem here with a quadratic constraint, that is x squared plus xy plus y squared equals 3, and we try to find mean and max of the quadratic, another quadratic here. Now notice, however, today we're going to use what is called a homogeneous form. Now what is that? You notice that both the objective function and the constraint polynomial are degree 2 for each term. Now we call that homogeneous because x squared degree 2, xy degree 2, y squared degree 2. So in this case, we can use a common trick for homogeneous form. All right, let's start. Now the trick is, if you have this, you can assume y equal tx. Now, however, notice that for that form, you probably want to make sure x, y are not 0, along 0. In this case, if x is 0, y squared equals 3, and then the objective function is also 3. All right, so we treat this as a special case. For the rest of the discussion, let's assume x is non-zero. So we can use the common trick, that is y equal tx. Okay, so use that. Of course, t is some value, some real number that we don't know, but it will help us to change the quadratic into a easier to manipulate form. So we plug that in to the equation, we get this. Of course, common term is x squared. We're going to take it out. This is equation number 1. For the constraint, we turn that into a variable t here, right? Now, what is about the objective function? Objective function is also homogeneous form, right? So in the objective function, if we plug in y equal tx, we're going to have this. Again, x squared is a common term. Let's take it out. So s equal this form. Now notice that we have two equations, equation number 1 and number 2. We try to cancel x squared. Okay, so s is our objective function, and equation number 1 and number 2, let's do that. Let's divide 2. Let's use equation number 2 divide equation number 1. Okay, let's do that. So that's a fraction that x squared is gone. Now, right now, we have a function with t, which represents the ratio of y and x, right? And s, which is our objective function. We try to find the mean and the max value of it. All right, so let's take a look at this. So here, just to recap what we got earlier. So we have this. So you can use cross product for this fraction, right? So you have this equation here. Again, we're going to combine terms so that this becomes an equation in t. Okay, a quadratic equation in t. Okay, that is this one. Equation number 3 is something we're going to work with. All right, so let's try to solve the problem now. Now, when you look at this problem, it's a quadratic problem. S is some value we don't know. This is s is objective function. Now, what is t? Remember, y equal tx and xy are non-zero, we assume, right? In other words, t equal y over x is a real number. So this equation must have real number as roots. What is the condition for that? Discriminant must be greater or equal to 0. So that's the key here. So in other words, s cannot be any real number. S must be constrained so that this value is greater or equal to 0. Discriminant of quadratic equation is b squared minus 4ac. Let's do that. So that is the equation that s must satisfy. I mean this inequality, right? So if you simplify that, it becomes this. All right. Further simplify, divided by -3, the equation will change sign, so it becomes this. Now, of course, this will give you a range for s in order for this inequality to hold. That is, s must be in between 1 and 9, right? This quadratic has this property here. So in other words, we know s must be 1 and 9 in order for the original equation to take t as the roots, right? so that the equation in T would have real roots. Okay, what is S? Remember, in the special case of x equal to 0, y squared equals 3, that is in that range. In other words, in the special case, it won't take the mean or max value. The mean value is 1, the max value is 9 of the original problem. Okay, so this what we have for this method. Okay, so last time we introduced a linear transformation method where we also get the same result. You can refer to the video, check out the description for the link. Hope you like the video. Please share and subscribe.